It's been a while since I recorded the videos, our tutorial sessions. So welcome back. So today I'm going to continue to work on this is where we were. And we have decision trees and logistic regression. And it's time to add one more node named a neural net. So let me add a neural net. So neural net is under model tab, as you can imagine. So neural is right here. And I'm going to place it along with logistic regression. All right. So, and then going to connect impute to neural net. And within neural net, if you select that, these are the properties. You can make adjustment. I'm going to select optimization. And here I'm going to disable the preliminary training because with preliminary training, it just takes longer time. So in the interest of time, I just disabled it. That's the main reason. And without making any further changes, I'm going to run the neural net. Yes. So you may guess, this can be the right approach. Knowing the fact that a neural net in Enterprise Miner does not have any input selection, sort of built-in input selection mechanism. So we should rely on another supervised data mining model like logistic regression to perform input selection. But now, for the sake of illustration, I'm showing you sort of demoing the case in which I didn't perform any input selection, and this is what would happen in the absence of, without input selection. You can imagine the model it's likely overfit the data we have, and let's see whether that is the case. Still running. Drink some water. Well, faster than I thought. So here are the results. So within the results window, going to maximize the fit statistics. Take a look at the third row, the degree of freedom, basically the number of inputs included in the model. It says 253, which is a lot bigger than those, that we saw from other models, decision trees and logistic regression. Basically, this is the number of parameters included in the model. So the model itself is highly parameterized, meaning that it's likely overfit the training data set we have. So it sort of confirms what we expected. And as a result, the second from the bottom line, the misclassification rate, if you compare those between training and validation sets, the difference is remarkably huge, suggesting the fact that, the training set, the number from training set is a lot smaller than that in the validation set, suggesting that the current model sort of overfits the data provided by our training set. So it sort of successfully minimized the errors in a training set, but when it was evaluated on a validation set, the error rates increased. So that's not a good sign. Basically, the larger the gap between these two numbers, more likely that you basically overfit the training set. Okay, so next thing, I'm gonna exit this window. and then go back to the optimization option we had, and going to increase the number of iterations to 100. And this is basically the higher number you put here, the model will sort of exhaustively search the values of each parameter, each weights we have in the network, in the neural network. So it just, we're indicating the maximum number of iterations. It doesn't mean that all our neural nets will iterate as many as 100 times. No, it's just maximal level. It can go up to 100, but in many cases, it will stop running it like within 30 to 40 iterations. So that's the change we need to make. And let me select OK. All right, then the next business we have is the input selection. So since neural net does not have its built-in input selection function, we would rather rely on another model to perform input selection. So to do that, I'm going to delete this link and then connect neural net. So basically connect logistic regression to neural net. So when we run a neural net, we will use the select set of inputs based on logistic regression. If you remember, we used stepwise selection method to perform input selection in this logistic regression. So to piggyback on what the logistic regression offers with regard to input selection. So I'm going to update this new path. So select update. Take some time. All right, so the path being updated. So within neural net, I am going to look at its variables list. So within training, have that right under it, select variables. And it indicates which inputs are entered. Which inputs enter the model, the neural net model. So the fourth one, the median home value was used as an input, whereas all the first three inputs, they exist in our data set, but they are rejected by stepwise selection method in our logistic regression. So they do not enter our neural net. So at the end, 1, 2, 3, 4. Only 4 inputs enter the neural net model we have. So select OK. And I'm going to run the neural net. Hopefully it runs quick. This here. We are getting there. So we are imputing, finally running logistic regression one more time, and then, neural net. So we're kind of anticipating the difference between, the misclassification rates on a training set and on a validation set. The difference between the two should be smaller this time, since we carefully perform input selection by capitalizing what the logistic regression has already done. So that's what we're expecting out of this neural net model, and see if it conforms our expectation. All right, there you go. Check out the results. So as you anticipated, if I look at misclassification rates, the difference between the two, only sort of there is the basically 0.006 difference. So the only difference happens at the third decimal point. So in other words, the model sort of improved is model fit. It does not overfit the training set anymore. So that's all I have for this.